Okay, so tonight we have the exam. I sent you an announcement, 6 to 8 for standard time and 6 to 9 for extended time room. Okay, let's do a review of the concept. First lecture 10 and 12, Thevenin and Norton equivalent circuits. The reason lecture 11 is not here is because lecture 11 was exam 1 review, okay? So that wasn't a lecture actually. You need to remember and you need to know the definition of Thevenin equivalent circuit and Norton equivalent circuit. So Thevenin equivalent circuit consists of a voltage source in series with a resistor. And Norton equivalent circuit is a current source in parallel with the same resistor or with a resistor. You need to know how to calculate these parameters, these quantities. For example, what should you do if you want to calculate the Thevenin voltage? Open circuit voltage measured across the terminals that you're interested in, okay? When I say open circuit, I mean the load shouldn't be connected to those 2 points, okay? But I don't mean anything that is part of the network should be opened, okay? So only the load shouldn't be connected, meaning that nothing except the network itself should be connected to those 2 terminals. And how about I Norton? How do you calculate I Norton? The short circuit current flowing between those 2 same terminals that you're talking about. Now, what should we do to the circuit if we want to calculate either VTH or I Norton? What should we do about the independent sources? Nothing, okay? Just leave them be. I Norton and V Thevenin do nothing to the independent sources, okay? When do you actually need to do something about them? For Thevenin resistance or equivalent resistance, right? From across the 2 terminals, you see how much resistance you're sensing or you're calculating, while all the independent sources are dead. How do you kill independent sources? Voltage sources replaced by short circuit and current sources replaced by open circuit. Remember that R Norton and R Thevenin are exactly the same thing. That's why we most of the time call both of them R Thevenin, which is also called equivalent resistance. Now, in order to calculate the resistance between 2 terminals, the easiest way is to see if we can do any resistor combination and combine all the resistors. But sometimes it's not possible. Sometimes the resistors are complicated. The arrangement of the resistors is complicated and you cannot do resistor combination. And sometimes you have some elements that actually makes it impossible to use resistor combination. What is that element? Dependent source, right? If there is a dependent source in your network, there's no way you can combine resistors. So what is the method that you should go for? Test source method. Either a test voltage source or a test current source. You choose the value of your source yourself, usually 1 volt or 1 amp, it doesn't matter. And then you will calculate the other parameter. For example, if you're applying a test voltage source, then you measure or calculate I test and then divide V test by I test, and that will give you your equivalent resistance. The same scenario is for when you want to use the I test method. This is the summary of this method. We discussed it in class just for your review. Lecture 13 was about inductor. We have 2 definitions for inductors. The first one is the fundamental definition, physical definition of inductor, which is the magnetic flux divided by current. And the second definition, which is, I can say, more important, is how inductance is defined based on this based on its behavior. So inductance is actually a measure of how an element opposes or responds to a change in either magnetic field or current. Now, can you tell me what is the definition of capacitor similar to this? Yes, capacitance is a measure of how an element responds or opposes a change in voltage or electric field. And remember, this is the most commonly used equation for inductor. L di over dt is the voltage across the inductor. And remember, this equation is valid for the case where the current enters from the positive terminal. Okay? So if that is your V and that is your current, then you can write it like that. If it is the opposite way, it will need a negative sign. You learned how to work with the units. If you want to find the units, you just focus on the equation and you can find the units. Remember not to apply Ohm's law to inductors. Okay, this is exactly for that. Ohm's law doesn't apply to inductors. Inductors have their own equation, which I just talked about. V equals L di over dt. Whether it is V across the two terminals or V1 and V2, the individual node voltages, you can write the equation for inductors. Now, a very important behavior note for inductors. In DC circuits, inductors behave as short circuits. Okay? You know that. Now, I'm going to ask a question and then see. I don't want you to get confused about this. Now, when I say DC circuits, I mean everything in that circuit should be constant. Okay? So, for example, nothing should be changing. Okay? That's why in the circuits that have switches, there is another requirement in order to be able to replace an inductor with a short circuit. What is the other requirement? If there is a switch in the circuit, in a DC circuit, if there is a switch, we usually need another condition in order to be able to consider inductor as a short circuit. Yeah, it should have been in that position for a long time. Well, let me put it this way. Well, technically, saying DC actually has that definition embedded inside of it. Because when I'm talking about DC circuit, I mean nothing changes. But if I'm talking about the circuit right after switching, is everything constant? No. Everything is actually in the transient region. Okay, that's why we leave it for a long time, and then we can say, okay, now we can replace the inductor with a short circuit. Am I making sense to everyone? Okay, so that is one point I wanted to make. The opposite of the fundamental equation or the important equation that we had is the integral equation for when you have the voltage and you want to find the current. One thing that students sometimes forget is that they forget 1 over L to be multiplied by the integral. You can either use integration, or if these are geometric shapes, you can just calculate the area. Remember, above the horizontal line, positive, below negative, and then when you're calculating the area, you're only calculating the integral. So it should be multiplied by 1 over L and then plus the initial value, okay? So the area is only the integral part, okay? Another very important thing, it could be both fundamental or conceptual question, and it's very important for analyzing transient response questions as well. The current flowing through an inductor cannot change abruptly, okay? Now, about power, absorbed power. If the current is entering from the positive terminal of the voltage, and if you multiply voltage and current exactly as before, we had it in the first exam. If you multiply voltage and current in this polarity, you will get the absorbed power. Okay? Nothing different than a resistor or a voltage source. VI is always your power. Now, one formula is very important for your exam, in the sense that sometimes you get it confused with, you get it mixed up with the equation for power. It's not for power. It's for absorbed energy or received energy or stored energy, whatever. It's 1/2 Li squared. Do you remember the equation that gives you the energy for capacitor? 1/2 CV squared, okay? So I want you to remember these are about energy, not power. If the question is asking power, how do you calculate it? VI. If you have the equation, if you have some function for energy of some element, whatever that is, and they ask you to calculate power, how do you do that? How do you change energy to power if you have a function for that? Derivative of energy is always power. Remember that. What if you have the power? Integral of power is energy. Okay, always remember, if power is multiplied by time, think of keeping that on for a long time. It has certain amount of power absorbed or consumed. The longer you keep it on, the more money you're going to pay for your electricity bill, okay? Because you're consuming more energy. Combining inductors, very easy, exactly like resistors, okay? If they are in series, you add them. If they are in parallel, you use the relevant formula. The fundamental equation for capacitor, lecture 14, is Q over V, okay? What was the dual of this equation for inductors? Phi over I. Q over V, phi over I. You also have one equation for a structure, or the structural equation, geometrical equation of the capacitor, which is epsilon A over D. A is the, this is for parallel plate capacitor, and you know the parameters. This could be a fundamental or conceptual question. Remember that if a capacitor is electrolytic or polarized, what happens if you connect it backwards on a circuit, in a circuit? It will explode, okay? It will be permanently damaged. You cannot use it anymore, okay? This is the definition of capacitance. We talked about that. The equations are very similar to the equations of inductance. I mean, they are actual dual of them. And remember, Ohm's law does not apply to capacitors. Again, in DC circuits, capacitors behave as open. The voltage cannot change abruptly across the capacitor, and the equation that gives you voltage from current. Again, don't forget this guy. The energy of the capacitor, you said it, 1/2 CV squared. And remember that when you are combining capacitors, they are exactly behaving the opposite of resistors. So if they are in series, you use the parallel equation or formula of resistor. And if they are in parallel, you just add them. Lecture 15, 16, and 17, which are transient analysis. Lecture 17 wasn't actually anything, if you remember. That's the Wednesday that I was absent, but I mean, you had your in-class assignment and web work. It wasn't a new concept, it was just some sample examples. Now I'm going to ask you a series of questions, and please try to answer them because they are very important for today's exam. I'm going to do a transient analysis on a circuit. Let's start with step 1. Analyzing the circuit right before switching, T equals 0 negative. What can I do to the circuit to simplify it? T equals 0 negative right before switching, and the circuit has been in that position for a long time. Short circuit for inductors, open circuit for capacitors. Okay, this is what you do to the circuit. And then based on that, remember always, when you replace the inductor with a short circuit, one thing that could happen is a resistor gets shorted out, okay? I'm not saying always, but always keep an eye on that, okay? That's the first step. But in the first step, what do we need to calculate? We did the circuit, we simplified it. What do we need to calculate? The current of the inductor, definitely. No matter what the question is asking you, the current of the inductor or the voltage across the capacitor should be calculated. No matter what the question is asking. Can you tell me why? Because you need it for the next step. Now, can you tell me in the next step, which is t equals 0 positive, what do you do to inductors or capacitors? Replace them with a source. Inductors with a current source and capacitors with a voltage source. And what is the value of the current source or voltage source? The value that you found for them in the previous step. What's the reason? Because they cannot change abruptly. Okay, I want you to know the process with the reasons so you won't forget them. What do you calculate in the second step? Whatever quantity that the question is asking, okay? You should focus on whatever quantity is asking. What is a step 3? Infinity. What are the things that you can do to the circuit to simplify for t equals infinity? Short for inductors, open for capacitors. Why? Because the circuit is not changing anymore, okay? Everything is in DC form, it's not changing. Step 4. What do you do to the circuit for step 4, which is time constant calculation? From which to terminal? No, they don't give you any terminal. You should be able to understand which terminals you should consider. The terminals that the inductor or the capacitor is connected. The first thing you do, you remove the capacitor and inductor. You don't need that for equivalent resistance, okay? Then from the terminal that it leaves behind, you calculate your equivalent resistance, okay? And what do you need to do before your circuit analysis? Kill the independent sources. We already talked about that. Don't forget that. If you don't do it, you will get a different answer. Yes?
So in every situation, we just kill the independent sources for, if you're trying to find resistance, I mean.
Yes.
Always.
Yeah. For equivalent resistance, always kill the independent sources. And what if you couldn't combine resistors in order to find the equivalent resistance? What do you do then? Test source method, okay?
And actually, there's a dependent source.
If there's a dependent source, I hope you don't see that on exam, but sometimes the circuit is only resistors, but it's still impossible to combine them. Yes. And the fifth step, you should memorize this equation set, okay? Very, very important. And plug in all the values into this, and it will give you the whatever you want. And remember, usually the last question in a series of questions related to one transient analysis circuit is to find the value of a specific voltage or current at a specific instant of time. What do you do after the fifth step? You plug in the time value into the equation, and you will find the value, okay? Did that make sense? Except this equation, is there any set of equation that we need to memorize for exam? No. This is the only one. It will give you the total response. You don't need to memorize those separate equations for natural and forced response. This is all you need because it will automatically adjust itself based on the conditions of the problem. For example, if y infinity is 0, it will give you the natural response automatically. Okay? So this is the only thing that you need to memorize for the exam.
So we're gonna have all the energy equations given to us?
Nothing is given to you. No equation is given to you. That's for third exam that you get formula sheet. Yeah. No equation is given to you. Whatever is in that document, you need to memorize.
So for the third exam, we make our own?
No, I will give you the full equation list for the third exam. Now, the definition of time constant. What's the definition of time constant? The amount of time it takes for the signal, whether it's voltage or current, to fall to 37% of its initial value. That could be a conceptual question. After how many time constant the signal will fall below 1% of its initial value? 5, okay? This is the table. Do you need to memorize it? Absolutely not. Would it hurt if you know the 5-1, the 5 tau? Probably yes. But these are very easy calculations. Okay, these are some questions that the students have asked. You can refer to them after I upload it. If you have any questions, let me know. Any questions about past exams? These are some of the equations that the students in the previous section or last quarter have asked. Any question? Yes?
Just quickly go over the first things you taught in the first minutes of class.
Pardon me?
Could you go over the first, just really quickly directed recap what you taught in the first 2 minutes of class?
When did you arrive?
10 minutes later.
Okay, if there is any questions, because I'm not going to repeat it because I'm recording, after I'm done with everything, I can explain it to you. Okay. No questions? Okay, see you tonight. Bring pizza. Huh? It's late, we can have some dinner in the exam.
I'll give us.